this section, we're going to be looking at linear functions and slope. And out of that section, we're going to be calculating the line slope, writing the point-slope form of the equation of a line, writing and graphing the slope-intercept form of the equation of a line, also graphing horizontal or vertical lines, recognizing and using the general form of a line's equation, also using the intercepts to graph the general form of a line's equation. All right, we'll begin with defining what a slope is. And by definition, the slope is the measure of a line's steepness. Now, an illustration of that would be probably a ramp that handicapped individuals use to obtain access to a building. Usually that ramp is an illustration of a slope because it has steepness. Okay, and slope is used to measure that line's steepness. And the slope compares the vertical change, which is the rise, to the horizontal change, which is called the run. And then when we want to calculate the slope of a line, we use a ratio that compares the change in y, which is the rise, to the corresponding change in x, which is also the run. Okay. And here's the definition of a slope. The slope of a line through two distinct points, x1, y1, and x2, y2, is going to be this. And we use the lowercase m for the slope. So the m is equal to, and it's going to be this formula, y2 minus y1. That's the change in y, which is your rise, divided by the corresponding change in your x coordinates, x2 minus x1. And the condition here is that x2 minus x1 cannot be equal to 0, because if it was, then you would have no slope, which we'll discuss a little bit later on this video. And we're going to use this particular slope formula to work out these two problems here. Let's say we want to find the slope of a line passing through each pair of points. And in this case, part A has -3, 4, and -4, -2. Okay, so here, these are my 2 points, and I want to find the slope of the line passing through those 2 points. Okay, now here's what I'm going to do here. This first point is -3, 4. x1 will be -3, y1 will be 4. The second point is -4, -2, so x2 will be -4, and y2 will be -2. And then we use the slope formula. M is equal to y2 minus y1 divided by x2 minus x1. Now in this case, y2 is -2 and y1 is 4. So y2 minus y1 will be -2 minus 4. Divided by x2 minus x1. Well, x2 is -4 and x1 is -3. So x2 minus x1 will be -4 minus -3. And then we're going to simplify the numerator and the denominator. -2 minus 4 is like -2 plus -4, that's -6, over -4 minus a -3 is the same as -4 plus 3, which is -1. So now you're going to have -6 over -1, which is simply 6. So the slope of that line passing through those 2 points will be 6. Okay, so this is part A. Part B is this. Here's the other set of points, 4, -2, and -1, 5. So we have 4, -2, and -1, 5. And we want to find the slope of that line passing through those 2 points. All right, in this case here, I'm going to let x1 be 4, since it's the first point. and y1 be negative 2. That's y1. And then x2 will be negative 1, and y2 will be 5. So now we have the formula for the slope. M is equal to y2 minus y1 divided by x2 minus x1. All right. Now for y2 minus y1, that's 5 minus negative 2. And then x2 minus x1 is negative 1 minus 4. Okay, so in this case here, 5 minus a negative 2 is 7. Negative 1 minus 4 will be negative 5. So we got negative 7 over negative 5. And 7 over negative 5. And I'll just leave this as negative 7/5. And I'll leave that as an improper fraction. So the slope of that line passing through those 2 points will be negative 7/5. All right, so do be familiar with how to calculate the slope of any line passing through 2 points. Okay. Now let's look at the 4 possibilities for a line slope. Okay. There are 4 possibilities, and we see 2 of them right here. One of them is a positive slope where the line rises from left to right. So if you have a positive slope, the line will rise from left to right. A negative slope means that the line will be falling from left to right. That means that your slope is negative. The other 2 possibilities are zero slope and undefined slope. Zero slope means that the line is horizontal. Okay. And then undefined slope means that the line is vertical. So we want to say undefined slope and not say no slope. We want to clarify that and say that the slope is undefined, which means that this line is vertical. All right, next we'll look at the point-slope form of a equation of a line. The point-slope form of the equation of a non-vertical line with slope m that passes through the point x1, y1 is going to be this formula. Y minus y1 is equal to m times the quantity x minus x1. This is the formula that we use to find the slope of, the equation of any line when you're given a slope and a point. Okay? That's why it's called point-slope form, because you must be given a point and a slope to even use this formula. And here's an example of just that. Let's say we want to write the point-slope form of the equation of the line with the slope of 6 and passing through the point 2, negative 5. And then you're going to solve this equation for y. Okay, so here's what we're going to do here. We know 2 things. Our slope is 6. So here I'll just say m is equal to 6. And we have the point 2, negative 5. That's given to us. Okay, so here we got a point and a slope, so we can go ahead and use the point-slope form, which is in this case y minus y1 is equal to m times the quantity x minus x1. So with 2, negative 5, x1 will be 2, y1 will be negative 5. So we're going to replace the y1, the m, and the x1 in this point-slope form. So here we're going to have y minus y1, which is negative 5. That's equal to m, which is 6, times x minus x1, which is 2. Now, y minus the negative 5, I'm going to rewrite that as y plus 5. And that's equal to 6 parentheses x minus 2. Now, this equation is written in what we call point-slope form. That's point-slope form. Now, we want to solve the equation for y. What we'll do here is take this and just simplify it. Okay, so let's bring down y plus 5, and that's equal to, the right side will use the distributive property. 6 times x, that's 6x, minus 6 times 2 is 12. So we got y plus 5 is equal to 6x minus 12. And then when we subtract 5 on both sides, you're going to get this equation. Y is equal to 6x minus 17. That equation is solved for y. So the equation solved for y, that has the slope of 6 and passes through the point 2, negative 5, will be that equation. Y is equal to 6x minus 17. Okay. Now, let's say you were given 2 points. In this problem, you're asked to write the point-slope form of the equation of the line passing through the points negative 2, negative 1, and negative 1, negative 6, and then solve the equation for y. So here we're given 2 points, negative 2, negative 1, and negative 1, negative 6. Okay? And we want to write the point-slope form of the equation of the line, of that line. We can still use the point-slope form. However, we need to find out what the slope is because we're only given 2 points. So we first use our slope formula, which is, of course, m is equal to y2 minus y1 divided by x2 minus x1. All right, in this case here, y2 minus y1, I'm going to let this be y2, which is negative 6, and y1 be negative 1. So I'm going to have negative 6 minus negative 1 divided by x2 minus x1. Now, if I let this be y2 and this be y1, then this will have to be x2, and then this will have to be x1. Negative 1 minus negative 2. Now, let's simplify this. Negative 6 minus a negative 1, that's going to give you negative 5, divided by negative 1 minus negative 2, that's going to be 1. So we're going to have negative 5 divided by 1, which will be negative 5. So the slope of that line is negative 5. Okay, so we know what the slope is. Now, to use our point-slope formula, we have to use that slope of negative 5, and we can use either one of these 2 points here. I'm going to use the first point, negative 2, negative 1. Okay, I'm going to use that in our point-slope form, which is y minus y1 is equal to m times the quantity x minus x1. Okay, so here x1 is negative 2 and y1 is negative 1. So here's what I'm going to have. Y minus negative 1 is equal to m, which is negative 5, times x minus negative 2. Now I could have used the second point, and I'm still going to get the same equation once I finish this out. Now y minus a negative 1 is the same as y plus 1. That's equal to negative 5 times the quantity. Now x minus negative 2 is the same as x plus 2. That equation is written in point-slope form. So this is the point-slope form of the equation of that line passing through those 2 points, negative 2, negative 1, and negative 1, negative 6. But we're also asked to solve this for y. So in this case here, we'll just finish this out. We'll do y plus 1 equals, now use the distributive property, negative 5 times x is negative 5x. Then negative 5 times plus 2 will be minus 10. So it'll be y plus 1 is equal to negative 5x minus 10. Now we need to get the y by itself. So here we'll subtract 1 on both sides. So that means we're going to have y is equal to negative 5x minus 11. And that would be your equation written, well, solve for y. That represents the equation of the line passing through the points negative 2, negative 1, and negative 1, negative 6. And that's the equation y is equal to negative 5x minus 11. Okay, so notice that with 2 points you must find the slope using the slope formula. And then you can use either one of these 2 points. I use the first one, but you can use the second point, negative 1, negative 6. Now, the point slope form may be a little bit different, but the final expression solved for y will still be the same. Okay. Now, let's talk about the slope-intercept form of the equation of a line. Now, the last 2 equations that we looked at, where you were told to solve for y, those equations were written in slope-intercept form. So here the slope-intercept form of the equation of a non-vertical line with the slope of m and the y-intercept of b is this. Y is equal to mx plus b. All right, and in the equation of a linear function, the x coefficient is the line slope, and the constant term is the y-intercept. So in this case here, for y is equal to 2x minus 4, the 2, that's the number in front of x, that's your slope. The negative 4 is your y-intercept. And then for f of x is equal to 1 half x plus 2, here the 1 half, which is the number in front of the x, that's your slope. The b, the 2, is your y-intercept. Okay, so yeah, as you can see, both of these are in slope-intercept form, and those equations have to be written in slope-intercept form before you can identify the slope and the y-intercept. And we can graph a linear equation that's in slope-intercept form by just using the slope and the y-intercept, and it's just 3 steps. Number 1, you want to plot the point containing the y-intercept on the y-axis. Then number 2, obtain a second point using the slope, which is m, and then you're going to use the concept of rise over run, starting at the point containing the y-intercept. And then the third step is to draw the line through those 2 points. Okay, so that's the procedure for graphing any linear equation that's written in slope-intercept form using the slope and the y-intercept. And here's one example of just that. Here we want to graph the function, or the linear function, f of x is equal to 3/5 x plus 1. F of x is equal to 3/5 x plus 1. Okay, so here's the equation. Now we need to identify the slope and the y-intercept. As you can see, it is written in slope-intercept form. So here the slope is the number in front of the x. That's 3/5. The y-intercept, which is your b, that's going to be 1. That's the slope and the y-intercept. Slope is 3/5. The y-intercept is going to be 1. Now we're going to graph this on the coordinate plane. Okay. Now let's first plot the y-intercept. The y-intercept, which is your b, that's the 1. So you're going to go on the y-axis up to 1 and draw the point. That's the point where the graph is going to be crossing the y-axis. So we first plot the y-intercept. Now the 3/5, that's your slope. Now it's written as a form of a fraction, so the numerator is your rise, the denominator is your run. And I do need to point out, if your slope is a whole number, then you'll write that as that number over 1. So if the slope was 2, then it'll be 2 over 1. And the numerator is the rise, the denominator is the run. So in 3/5, your rise is going to be 3. That's going to tell me how many. That tells me how many places I need to go up or down from the y-intercept. And the run, which is your denominator, that's 5. That tells me how many places I need to go to the right. So with 3/5, we start at the y-intercept of 1. The rise is 3, so I rise up 1, 2, 3 places. And then the run is 5, so I'm going to run to the right 1, 2, 3, 4, 5, and draw the point. Okay, so with the slope of 3/5, the rise is 3 and the run is 5, so I went up 3 from the y-intercept and to the right 5 and drew the point. So now I only have my 2 points that I need to draw the graph of that linear function. F of x is equal to 3/5 x plus 1. So this is how we graph a linear function or linear equation using the slope and the y-intercept. Okay. Okay, let's look at equations of horizontal and vertical lines. We'll start off with the horizontal line. A horizontal line is given by the equation in the form y is equal to b, where b is going to be the y-intercept. So here, if you have y equal to a number, that means you can have a straight line crossing the y-axis at that particular number. And usually, functions that are expressed as f of x equals b are often called constant functions. So f of x equal to a number is going to be a constant function. Okay, and we're going to look at an example of graphing the equation y is equal to 3 in the rectangular coordinate system. Okay, so here we have the equation y is equal to 3. Now we can do an xy table like this. Okay, no matter what value I assign to x, the y has to be equal to 3 because the equation says y is equal to 3. So the y coordinate must be 3. The x coordinate can be anything I want to, like -1, 0, and 1. I can use those to do the graph. Alright, in this case, I'll plot the point -1, 3, and that's to the left 1 and up 3. And then 0, 3, we stay at 0 but go up 3. And then for 1, 3, you go to the right 1 and up 3. And then you're going to connect those 3 points, and you'll have the graph of the line y is equal to 3. Okay? So as you can see here, it's going to be a horizontal line. Okay? So anytime you have y equal to a constant, the graph of it will be a straight horizontal line. Okay? Alright, the next type of line will be a vertical line. And the vertical line is given by the equation in the form x is equal to a, where a is going to be the x-intercept. So here, we're going to have a vertical line crossing the x-axis at that particular number, a. So if you have x is equal to a constant, then that means it's going to be a vertical line. And none of the vertical lines are considered to be a linear function. Okay? No vertical line is considered to be a linear function. And the reason for that is on the vertical line, your x-coordinate is exactly the same. And of course, if you recall, if all your x-coordinates are paired with, if you have an x-coordinate paired with two different y-coordinates, and that means you wouldn't have a function. So here, this would be an example of a vertical line not being a linear function. Okay, let's look at how to graph this one. Let's say we had the linear equation x equals -3. And I want to graph this linear equation. X is equal to -3. If I use an xy table, my x-coordinate has to be -3 because of the fact that the equation says x equals -3. The y can be anything I want. Let's say -1, let's say 0, and I'll say 2. Doesn't matter what I make the y-coordinate, as long as the x-coordinate is equal to -3. Okay, let's graph this. -3, -1 will be to the left 3 and down 1. -3, 0 will be to the left 3, and the point will be on the x-axis. And then -3, 2 will be to the left 3 and up 2. Now connect those 3 points, and you'll have the graph of that equation. X is equal to -3. Okay. Okay. So that's how you'll graph a vertical line. Okay. So keep in mind, when x is equal to a constant, the graph will be a vertical line. But when y is equal to a constant, the graph will be a horizontal line. Okay. All right, we'll move on to the general form of the equation of a line. All right, every line has an equation that can be written in general form, which is in this case ax plus by plus c is equal to 0. In this case, a and b and c are going to be real numbers, and a and b are not both zeros. Okay, that's very important, because if a and b were both 0, then you would not have a linear equation. Now, if only a was 0, then you'll just have like, an equation where y is equal to something. Or if b was just equal to 0, then you'll have an equation where x will be equal to some number. Okay, so a and b cannot both be 0. All right, now we can identify the slope and the y-intercept of an equation that's written in general form by doing these 2 steps. One, you want to solve the equation for y, and then you want to identify its slope, which is your m, and its y-intercept, which is b. And then from there, you can go ahead and do the graph of the linear equation using the slope and the y-intercept. Like in this particular problem. Let's say we want to find the slope and the y-intercept of the line whose equation is 3x plus 8y minus 12 equal to 0. And then you're going to use the y-intercept and the slope to graph the equation. So we got 3x plus 6y minus 12 is equal to 0. All right, the first thing we need to do here is get this y by itself. That means we need to move some terms over to the opposite side. Okay? So what I'm going to do here, I'm going to have 6y on the left side. And then that's equal to, now, when I move that 3x over to the opposite side, I'm going to have a negative 3x. And if I move the minus 12 over to the opposite side of the equation, I'm going to have plus 12. So I'm going to have 6y is equal to negative 3x plus 12. And then, to get the y by itself is being multiplied by 6, I'm going to divide each and every term. in this equation by 6. So that means I'm going to have this equation y is equal to negative 3 over 6 will be reduced to negative 1/2 x plus 12 divided by 6, that'll be 2. So here this equation is in slope-intercept form. That means that this equation is solved for y. Y is equal to negative 1/2 x plus 2. And from that I can identify the slope and the y-intercept. Here the slope is negative 1/2. The y-intercept is 2. And from that, I can use that slope and the y-intercept to graph this linear equation. So here's my coordinate plane. All right, now I'm ready to do the graph. The first thing I graph is the y-intercept, which is your 2. So on the y-axis, I go up to 2 and draw the point. Now my slope is negative 1/2. I'm letting the 1 be negative and the 2 be positive. So that means that the rise is going to be negative 1 and the run will be positive 2. Okay. The numerator will tell me how many places I need to go up or down. Now it's negative 1, so I know I'm going to have to go down from the y-intercept. The run is positive 2, so I know I'm going to go to the right 2. So starting from the y-intercept of 2, the rise is negative 1, so I'm going to go down 1 place from the y-intercept. The run is 2, so I'm going to go to the right 2 places and draw the point. Okay. Again, I just went down 1 and to the right 2 because the rise is negative 1 and the run is positive 2. Down 1 to the right 2. Connect those 2 points and you're going to have the graph of this equation. And that's the equation 3x plus 6y minus 12 equal to 0. Okay. So that's how you graph the equation that's written in general form. And as you can see, 3x plus 6y minus 12 is an example of an equation that is in general form. And we can write that in slope-intercept form by getting the y by itself. And from that, we can identify the slope and the y-intercept. Okay. Okay, now we want to look at intercepts. Mainly the x-intercept and the y-intercept. Okay, here we can use intercepts to graph an equation that is in general form ax plus by plus c is equal to 0. There are 3 steps. Number 1, you want to find the x-intercept by letting y equal 0 and solve for x. And you'll plot the x-intercept on the x-axis. Part B is finding the y-intercept by letting x equal 0 and solve for y. Actually, step 2. And then you're going to plot the y-intercept on the y-axis. And then the final step will be to connect those 2 intercepts and draw the line. Okay? It only takes 2 points to draw the line of any linear equation. Okay, let's look at an example here. Here we want to graph using the intercepts. 3x minus 2y minus 6 equal to 0. 3x minus 2y minus 6 equal to 0. Okay, that's the equation. Now we want to find the x-intercept and then the y-intercept and use those to do the graph. We first find the x-intercept. And to find the x-intercept, you always let y equal to 0 in this equation. So you're going to substitute y with 0. So we're going to have 3x minus 2 times 0 minus 6 equal to 0. Now, 2 times 0 will give you 0. So you're going to be left with 3x minus 6 equal to 0. And then you have an equation that you can easily solve for x. So you want to add 6 to both sides to get 3x is equal to 6. Divide by 3. You're going to get x is equal to 2. X equals 2 represents your x-intercept, because that's going to be the point where the graph is going to be crossing the x-axis at 2. So that ordered pair is actually 2, 0. That's your x-intercept. Now we want to find the y-intercept. To find the y-intercept, you let x equal 0 and solve for y. Okay, so we're going to replace the x in our equation with 0. So you can have 3 times 0 minus 2y minus 6 equal to 0. And here, 3 times 0 is 0. So you're going to be left with negative 2y minus 6 equal to 0. And then to get the negative 2y by itself, you want to add 6 to both sides to get negative 2y is equal to 6. And then to get the y by itself, we divide by negative 2. And y is going to be equal to negative 3. So y equals negative 3 will be your y-intercept, because that's the point where the graph of this linear equation will be crossing the y-axis. And the actual ordered pair will be 0, negative 3. Okay. Now we're going to use those two intercepts, the x-intercept and the y-intercept, to graph our linear equation. Okay. First we plot the point 2, 0, which is your x-intercept. That means that the graph will be crossing the x-axis at 2. So at 2 on the x-axis, we're going to draw a point there. And for negative 3, which is your y-intercept, we go on the y-axis and go down to negative 3 and draw the point, because that's the point where this graph is going to be crossing the y-axis. So all I need to do here is connect those 2 points, and this will represent the graph of the equation 3x minus 2y minus 6 equal to 0. Okay. So be familiar with how to graph a linear equation using the x-intercept and the y-intercept. Okay. Now I realize that we have covered a lot in this particular section. So here is just a summary of all the equations of lines that we discussed in this video. We've discussed the point slope form, which is y minus y1 is equal to m times the quantity x minus x1. Okay? You have to be given a point and a slope in order to use that formula. If you're given 2 points, you first must use the slope formula, m is equal to y2 minus y1 divided by x2 minus x1, in order to use that point slope form. Then the second was the slope-intercept form, which is y is equal to mx plus b. That means you solve the equation for y. The horizontal line is always y is equal to some constant b, and the vertical line will be x is equal to some constant called a. And then finally the general form, which is ax plus by plus c is equal to 0. All linear equations can be written in general form, ax plus by plus c equal to 0. Okay, so that will conclude this particular section on linear functions and slope.